Alright, you do not have to write all that down, just write down partial fraction decomposition if you write stuff down to label your notes. Partial fraction decomposition is the short term of all of that. Okay, what we're going to do today is take a fraction and then break it into parts. And that's where the decomposition comes into play. We're taking something and we're breaking it up. Alright, the reason why we do this is in calculus, there are some fractions that we cannot integrate. But if we can break them into parts like we're doing today, we can integrate each of their parts separately. So those of you going to calculus, this is used in calculus. Those of you not going to calculus, but you are going to college algebra, this is something that is also done in college algebra. Alright, 3 examples. Alright, so I have the fraction 2x plus 5 over x squared minus x minus 2. So what I want to do is break this up into fractions. I want to decompose it. So, step number 1 is factor your denominator. So what does x squared minus x minus 2 factor into? X minus 2, x plus 1. So then we take these 2 factors and we make 2 fractions. I'm going to do a over x minus 2 plus b over x plus 1. It does not matter if the x plus 1 or the x minus 2 comes first. Okay, I'm going to have a over 1 and I'm going to have b over the other. So factor and then write it as multiple fractions. Okay. Step 3, and you really don't have to write this down, but I'm going to show you what it is we're doing so that you understand what we're doing. I'm going to multiply everything by my denominator. Okay, so you do not have to write this. So what happens is, when I take that times the original fraction, what happens? The denominator gets canceled out, and I only have 2x plus 5. When I take that times a over x minus 2, what cancels? The x minus 2, so I have a times x plus 1. Then I have x minus, or have that times this fraction, the x plus 1 cancels, so I have b over x minus 2. So that is technically what you are doing. However, all I really have to do is go a times x plus 1 and b times x minus 2. But I wanted to show you what it is that you're technically doing on that step. Okay, so we want to factor, we want to write it as multiple fractions, and then we want to multiply by the denominator. Next thing we want to do is distribute the a and the b. So ax plus a plus bx minus 2b. Bless you. Next thing we want to do is put the x's next to each other. So I want to put the ax and the bx next to each other. So 2x plus 5 equals ax plus bx plus a minus 2b. What property allows me to do that? Commutative. Associative is when you just move the parentheses. Commutative is when you start moving stuff around. Alright, so once we get the x's next to each other, what do you think we're going to do here with these 2?
I got an x.
Take out an x. Good. Alright, so here's where you're going to have to work to understand what's going on here. I have this thing right here is equal to that. I have an x here that has a 2 in front of it. I have an x here that has a plus b in front of it. What can I do with those two things?
A plus b is 2.
A plus b equals 2. Very good. In order for these two things to be equal, and I've only got one x on the right and I've got one x on the left, the coefficients of those x's have to be equal to each other. Everybody buy that? Okay. So, I've got a 5 here. What does that 5 have to equal?
A minus
It has to
2b.
equal to a minus 2b. Okay. Now we want to use some substitution to figure out what a and b are. So over here on this first one, I'm going to, let's get a by itself, so let's subtract b over. So that means a equals 2 minus b. Now what can I do? Or what do I want to do?
Do you add 2b from the 5 to the 5?
Nope. What's the purpose of getting this a by itself here?
So you can plug it back in.
So I can plug 2 minus b in for what? A over here in the other problem. But once I get a by itself here, I take this and plug it into a in the other problem. So 5 equals 2 minus b, and then minus 2b. Now I can figure out what b is. So I subtract that 2, which gives me 3. I put the b's together, which gives me negative 3b. Who are we waving at? Davis?
Yeah.
That's what I wrote.
So that means b equals negative 1. What do I do with the negative 1?
Plug it in.
Plug it in over here. So if I plug negative 1 in here, that makes it a positive 1 plus 2. That tells me that a is equal to 3. Once I find a and b, now I'm ready to write my final answer. So my final answer is going to be that with the a and the b plugged in. So I plug 3 in, and I plug negative 1 in. So what I have done is taken this original fraction here and decomposed it into 2 separate fractions. This original fraction I cannot integrate. These 2 separate fractions I can integrate separately. That's the purpose of it. What should happen if I get a common denominator between these 2 fractions and put them together?
You should get what you started.
I should get what I started with. So I'm going to show you that one time. I'm not going to do it on the other 2. But I'm going to show you that that's what it is that we did. So, common denominator. So I know my denominator is going to end up being this because it came from that. So x squared minus x minus 2. I need to multiply the 3 by the x plus 1, so that gives me 3x plus 3. I need to multiply negative 1 times the x minus 2, which gives me that. 3x and negative x give me 2x. 3 and 2 give me 5. And as you see, that's what we started with. So we were taking our original fraction and decomposing it into separate fractions that we can deal with. That's what we're doing today. Okay. So let's go through the steps again. What's our first step? Back to the denominator. Second step?
Multiple fractions.
Multiple fractions. Third step?
Multiply everything by the denominator.
Multiply everything by the denominator. Fourth step? Distribute. Fifth step? Get the x's closer together. Sixth step? Factor out the x. Seventh step? Well, I would set. I would get my 2 equations. Find my 2 equations on that step. Then I'm going to solve for one variable, make the substitutions, and find A and B. Once I find A and B, I plug it back in, and there's my answer. So in this case, the answer we're searching for is that right there.
So you don't have to write it
No.
down.
You gotta keep up.
I didn't know you had to get the original out of it.
I was laughing so
I was too busy going back on something to erase really quickly.
All right, let's try another one.
Yeah, I wrote down most of the stuff. And I see.
So Blake asked me, what are you
All right, I have x plus 11 over 2x squared minus 5x minus 3. I want to find the partial fraction decomposition. Is what I want to do. So x plus 11 over 2x squared minus 5x minus 3. What's the first thing we want to do? Factor the bottom, which will involve slide and divide. So factors of 6 subtracted to give me 5.
6 and
6 and 1. Negative 6, positive 1. Don't forget to divide. So that gives me x minus 3 and 2x plus 1. What's next?
multiple fractions.
Write my multiple fractions. So I'm going to have a over x minus 3 plus b over 2x plus 1. Okay, what's next? Multiply. So I just end up with x plus 11 over here. So I need the a times the 2x plus 1, so that is 2ax plus a. I need the b times the x minus 3, so that is bx minus 3b. Matt, say again.
Oh, never mind.
Line, you good?
Wait, I'm understanding if that you put 2ax plus a.
I did a times 2x, which is 2ax. I did a times 1, which is a. I did b times x, which is bx. I did b times negative 3, which is negative 3b. All right, now what?
The x's
Put the x's next to each other. What's next? Factor out the x. So now we're ready to get our two equations. So 2a plus b, what am I setting that equal to? 1. A minus 3b, what am I setting that equal to? 11. Any questions on that set?
Yeah.
Gabriel?
Yeah, could you just explain that again?
Yeah.
Alright, if there's not a number in front of x, what's in front of x?
1.
1. So I've got x here, and I've got x here. Those two things have to be equal to each other. So that means if I got x and x, that means 1 and the 2a plus b have to equal each other. Okay? Then the only other parts are that and that. So those two have to be equal to each other as well. No, in this case, I would solve for b. So once you do that, you want to get one of these two by itself. In this case, b is easier to get by itself than a is. So I'm going to do 1 minus 2a equals b. So then I plug 1 minus 2a into the other equation for b. plug 1 minus 2a into the other equation for b. Distribute that negative 3. Add the 3 over, gives me 14. A and 6a give me 7a, so that means a has to be equal to 2. Plug that 2 back in over here, so that gives me 1 minus 4 equals b. So b has to be negative 3. So we stick a and b back into our fractions, and that's our final answer. So I have 2 over x minus 3 plus negative 3 over 2x plus 1. That is the answer we're looking for.
Instead of doing plus negative 3, can you do minus 3 over 2?
You can do that as well, that's correct. Question on that one? What do you think, Ryan? What's the difficulty level?
Go a little slower. But it's gotta be a little slower.
Remember, it's on video, so you can always go back and watch the video.
You just gotta remember what you need to do next.
Alright, last one. X to the 4th minus 3x cubed plus x squared minus 9x plus 4 divided by x squared minus 4x.
How's the difficulty level now, Rain?
Alright, we should notice this one looks different than the first two. What's different about this one?
Stack it.
Eventually, yes. What's different about this one? Alright, if you notice on the first two, what was the highest, how did the highest exponent of the numerator relate to the highest exponent of the denominator of the first two? The numerator was smaller on the first two. In this case, the highest exponent is larger.
So you did the numerator first?
If the highest exponent is larger, the first thing we have to do is divide. We've got to use long division. Oh man, can you believe that?
Blue was great.
Well, you better learn, folks. You better learn.
I feel like
It's good.
just long division in this situation. What's happening? So
The first two are like 2 and 6 are like the first two. 8 and 10 are like this one.
x
This is sad.
All right. So first thing I do is x to the 4th divided by x squared gives me x squared. So I do x squared times x squared gives me x to the 4th. I do x squared times negative 4x, which is negative 4x cubed. What's next? Switch the signs. So these can't, x to the 4th cancel. I get x cubed plus x squared. Do the process again. So what's x cubed divided by x squared? X. So x times x squared is x cubed. X times negative 4x is negative 4x squared. Change the signs. So negative and positive. X cubes cancel. X squared and 4x squared gives me 5x squared. Bring down the negative 9x. 5x squared divided by x squared. 5. So 5 times x squared is 5x squared. 5 times negative 4x is negative 20x. Change the signs. Negative 9x and 20x is 11x.
Plus 4.
Bring down the 4. Can x squared go into 11x?
No.
So what does that mean 11x plus 4 is?
The remainder.
How do we write the remainder?
11x plus 4 over 3.
Alright, so what we've done is we've taken our original problem and we've now turned it into that. We are happy with this, with the first 3 terms, the x squared, the x, and the 5. We are not happy with the last term. So the last term is what we need to work just like we did the first 2. Alright, so this right here is equal to x squared plus x plus 5 plus 11x plus 4. Those 2 things are equal. And like I said, we're happy with this. We just need to work on that other piece. So now we've reached the point where we're going to work it just like we did the first 2. So, x squared minus 4x, what does that turn into?
X minus
That turns into x times x minus 4. So 11x plus 4 over x times x minus 4. What do I set that equal to?
A over X
A over x
plus B over X.
plus b over x plus 4, or minus 4. Everybody with me?
Mm-hmm.
Do some.
Alright, what's our next step?
Start multiplication.
Multiply, so I get 11x plus 4 on the left. On the right side, a times x is ax. A times negative 4 is negative 4a. B times x is bx. Now what? Put the x's next to each other.
I got this.
So take the x out. So rain 11 equals what? A plus B. And 4 equals negative 4a. So in this case, it's going to be pretty easy to find a and b. Because I know a is already equal to negative 1. And I plug that in over here, which means I need to add 1 over. That tells me that b is equal to 12. So now I'm ready to write my final partial fraction. Okay, I need to start with this. So x squared plus x plus 5. And then I run into negative 1 over x plus 12 over x minus 4. That is our partial fraction. So on this one, the only difference between this one and the first 2 is I had to divide first, and then we worked the remainder just like we did in the first 2. So that's finding partial fraction decompositions of rational expression. All right, page 402, 2, 6, 8, and 10. Gabriel.